We were looking for a solution for auto-reclosure blocking scheme that has some key features that includes less maintenance. The price should of course be okay. Doing an installation of a digital substation and choosing new components, it's a key feature for us is that a supplier or a business partner like Alstom is able to secure backwards compatibility on a system, so that if we do a full installation on a substation and we return to the same substation in 10 years' time, we will be able to replace a given component in the chain without having to upgrade everything. And of course, another key feature would be that you are able to give us good advice. If you see a development in technology and you say, this could be an advantage for you to do an upgrade, or you have to be aware of this and that, that would be a main feature for us as well. The goal of the project was that we have a combined connection between two substations, and to be able to locate the fault precisely on two parallel cables, we looked into different solutions. So we were looking into a system where we could cover the two parallel cables separately. Basically, it's a blocking scheme we have here. If we have a fault on one of the parallel cables, we send a blocking signal to both ends. We actually inhibit the auto-reclosure scheme. The initial challenges of the project was actually doing the install, because with the conventional transformers, you have a way to separate the primary system to the secondary system via test plugs. Here we have a direct connection, direct fiber connection, and how to approach that. We have a reduced cost of installation. In a conventional scheme, you have to have a separate stand for the conventional current transformer. Here we could actually integrate the COSI directly on the same stand, and it gave us a big cost deduction actually. Another advantage, you say, is that it's fairly easy to install. You don't have all those copper connections and as much cabling as you've got to a conventional solution. Commissioning this system was initialized by the FAT test, the factory acceptance test in Villeurbanne, where we did a full scheme setup of all the system. We actually did a one-to-one setup of the whole system and simulated a primary injection. And that gave us a very, very good feel of the full system, because this was new to us. And we had to be safe and sure that when we did the installation, we didn't run into any problems that would postpone the installation process.
The grid has higher and harder requirements, such as higher voltage level, higher nominal and short circuit current. We have also, in the same time, environment and safety issues in the grid. The main characteristic of the equipment, I would say obviously the weight. Typically in our example, we can install the CT and the terminal bushing thanks to the lightweight in the same structure. The second one should be the non-saturation of the sensor. In the donut, in the white donut we have on the top of the CT, we have an optical fiber. There is no magnetic core and non-saturation. It makes easier for the engineering to define the CT. We are in a protected area in terms of environment, and the CT is free of oil, is free of gas, and then completely environmentally friendly.
Energinet would do a similar installation where we have a combined connection with overhead lines and parallel cables. Actually, that political decision has been made inside the corporation. So if we have connections like this, we for sure will do installation similar to this.